Alcohols are also excellent for an SN1 reaction. As always, we're going to start when we react an alcohol and we do one of the big four reactions, we're going to start with acid. Acid is going to be one of our key reagents. So let's look at this kind of reaction. We're going to treat this with methanol and sulfuric acid. And so sulfuric acid is H2SO4. I'm going to write out the full structure just to bring up a couple points. So anytime you mix a strong acid with another solvent, like water, like alcohols, that strong acid initially reacts with the solvent. So sulfuric acid, and anybody who's worked in lab and who's mixed strong acids with solvents knows that these things get hot. It's because the acid is protonated in the solvent. So whenever we mix strong acids in a solvent, the first step is always that our solvent gets protonated by the acid. And so even though our reagents are methanol and sulfuric acid, what you really have when you mix methanol and sulfuric acid is you have protonated methanol. Okay, that's important because when we do our first step of our reaction, convert our OH group into a leaving group, which is not yet, we are going to need to protonate that alcohol, and we're going to use the protonated solvent to do it. Do not use sulfuric acid. Now, it's okay if you don't always show this step, but this, if you are given something like water and sulfuric acid or methanol and sulfuric acid, you need to use this as your acid in your reaction. Regardless, after that long discussion, the whole point is we need to protonate our alcohol. And there's our protonated alcohol. And now we have a good leaving group so that O plus is saying, give me those electrons. And since it's a tertiary alcohol, we will, because we're going to form a tertiary carbocation. We need to form carbocations. We're talking about an SN1 reaction after all. And if we're going to form a carbocation, it better be a good one. Ideally a tertiary, perhaps a secondary. Now, what happens to our carbocation? Well, carbocations have two fates. They either get attacked or they lose a beta hydrogen. We're talking about SN1, so we're going to attack, and our nucleophile is going to be this weakly nucleophilic methanol. So even though we mix sulfuric acid with methanol, we have plenty of methanol. Some of it's protonated, some of it's still not protonated. And the molecules that aren't protonated will attack our carbocation carbon. That gets us to here. We've now accomplished our SN1 reaction. SN1, first we form a carbocation. Second, we attack that carbocation. Those are the two steps of. So this is SN1 step 1, and this is SN1 step 2. Now we have a step on the front end because we had to protonate to make our leaving group, and that's this first step. Now we're going to have a step on the back end, which is not part of the SN1, but we're not going to finish with this charged molecule. We need a base to come in, and methanol, which is in our reaction, is completely adequate for this. Sometimes people want to say, uh-oh, I need a base to deprotonate this. So what I'll use is hydroxide. You can't use hydroxide. The reaction is in acid, okay? So you can't just say, oh, I'm sure there's hydroxide in there. There is not hydroxide because you're in the presence of strong acid. So use the reagents that you have at hand. In this case, it's solvent methanol, completely adequate for this. And here's our net reaction. We've performed an SN1 reaction. We've replaced our OH group over here with a methoxy group. This is an SN1 reaction going through a carbocation, in this case a favorable reaction with a tertiary carbocation.